Hey guys, this is the first video in the OpenGL tutorial series. I know I had a legacy one. I'm basically discarding that, redoing it from scratch, and this is going to be the first video where I show you how to create a WIN32 window in an object-oriented way. So we'll create a GL app class, we will create a utility header, and we will set up our window to interface with OpenGL so that we can render to the pixels on our screen. So to begin, open up either Visual Studio 2010 or 2012, create a Visual C++ empty project, save it anywhere. I'm going to save mine to OpenGL, folder tutorials. I'm going to call this tutorial 1. Now once this opens, make sure it was an empty project and that you had create directory for solution selected off. It doesn't really matter, but the directory they give you is kind of wacky, so I explained that in one of my other tutorials. So to start, we're going to create a C++ file, call it WinMain, excuse me, and in here's where we're going to have our main entry point for our application. But first, we need to include windows.h, the Windows header file. So we're going to create a new class, called C++ class. We're going to call this GL util, our GL utility, for short. We're going to delete the class definitions. What we're going to do is we're going to define Win32 lean and mean, which that strips the Windows header file. If you don't know, it strips it of the socket, the networking stuff, and the cryptography stuff. Cryptography? I don't know. Maybe not cryptography, but networking, because we don't need networking for now. So we include that. Now we're going to include our utility for now in here, and we're going to set up the entry point. So that looks like this. Now I explained this in detail in one of my other tutorials, so you can look at that. The legacy OpenGL tutorial goes into this, but I'm just blowing through this real quick. So now that we have our entry point and it runs, let's see if this runs. Good. So what we're going to do is create a new class. We're going to call this one GL app. It's going to be our OpenGL app. Now, I missed a step. You could have had Visual Studio do it for you, but this is actually going to be a virtual destructor. There we go. For some reason, that was given an error. Okay, so here we go. What we're going to do is we're going to include our utility in here, and we're going to make a new constructor that takes in an H instance. We're going to make a public method called run. We're going to define one there, and we're going to define some framework methods. And these are going to be virtual. That one initializes our application. This is called every 60 frames per second to update our application, or even more, to be honest, because we don't limit it. And this is what's called a pure virtual function. If you don't know, by setting it equal to 0, it means that you have to define this because this is going to be an abstract class. So essentially we're just going to inherit from this to implement specific stuff for, let's say, a game engine or a game. This is our message procedure function. If you don't know, Windows applications work through a message pipeline where, depending on what you do to the window, to the application, a message will be sent to the Windows OS and handled accordingly by this message procedure function. So, here are our variables. We need an H window, handle to a window, an H instance, handle to an application. We're going to need an HDC, which stands for handle to a device context, an HGLRC, which is a handle to a GL render context, and we're going to need client width, client height, and app title, a frames per second counter, and what else do you think we need? I think that's good for now. Oh, we need one more thing actually. We need a dword window style, which I'll explain later. Okay, so now we're going to set up some methods. Init window, and initialize GL and OpenGL and calculate frames per second. So we're going to have a calculate FPS, which takes in delta time. So there we go. We have some good. Oh, and we should also have. Okay. Void shutdown GL, or just shutdown in general. Okay, so now that we have this, we can start implementing it. So first thing we want to do is get that constructor put in place. Takes an H instance. What we're going to do is set our app instance equal to that H instance. And then everything else gets set to null. All the other handles, I should say. Our client width should be 800. Client height. These can be overridden, of course, in the inheriting class to have a different window size. You can even override the message handler and make it dynamic, so you can drag the window to any size you want, have it scalable. Our app title, set that to OpenGL application. Our window style is going to be overlapped for this tutorial. System menu, caption, minimize box. And our FPS is going to be start at 0.0. And there we go with that. Now, next thing we're going to do is go over the main application loop. So what this is this holds our message loop. So what we're going to do is create a message struct. Now what this is this is an automatic initializer. So it takes the C struct and sets all of its it sets it to the empty set basically. So think of this as a set. We're setting it to the empty set, so we're setting all of its values to 0. There was a question about that on my on a previous tutorial. Someone said that it should be set to null, and I said no. This is different than null. This is setting it to an empty set, which is an auto setter. So we're going to check to see if this doesn't equal message.message. WM quit. Now I'll explain this when I go over the message handler, because it's interesting what happens basically. If message and message null. Whoops, sorry about that. It's Windows 8 freaking out. If you heard that. Null and PM remove. And here we're just going to no, we're not going to do that. Translate message and message dispatch message. I say and, but it's actually just the reference operator, so yeah, get my point. I should be clear about that. That's passing in a reference to the message. So here we're going to update. Pass in 0.0f for now. We're going to render. We're going to calculate FPS. Whoa, calculate FPS. Pass in 0.0. We're going to, if we ever break out, we're going to shut down, and then we're going to return static cast int message.wparam. So this will return basically the error message stored on why we actually broke out. So that's it. That's basically the main application loop. We'll be adding timing in a second. Might as well add it now, actually. So this is how you get delta time on Windows operating systems. So first, we'll start with a big integer. This is basically essentially a large integer. It's 64 bits, so it's very large. We're going to cast it to a large integer. We're going to get a counts per second variable, which is essentially the performance frequency, and that will be used to convert our units back to seconds so that we actually have correct delta time, and that's right here. Basically, it's the inverse of counts per second. Now here's where we calculate delta time. And this is used for smooth animation in games. Also locking things to a minimum CPU cycle, so that like if your computer is super fast, the game will still run the same speed on a super fast computer versus a really shitty computer. So current time minus previous time times our conversion factor. And there you go, that's delta time. So we're going to pass that in here to both of these. And finally, we need to reset previous time for next frame. So we set previous time equal to current time. And that keeps our timing in line. So next we're just going to handle initializing the WIN32 window. So basically we're going to create our window class X structure. I'm going to zero memory that. So basically set everything to 0, kind of like with the null set. Now these can be 0. We don't want any extra bytes. It doesn't really matter. The size of it is set to that. The style. This doesn't also really matter at all, but I do it anyway just to be absolutely sure, because since OpenGL will be taking over our buffer, we don't actually have to tell the window to redraw itself, because we're not using GDI, we're not actually using the built-in Win32 graphics. Next is our H instance, so that's our application instance. Now the next thing is our window procedure, so here's where I'm going to break off, and we're going to go down and basically define our message procedure. So just as it's defined before in our class, what we're going to do is we're going to do a switch statement on that message, and then do case wm destroy post quit message and return 0. Now, and then default, we're going to return def window proc, h window message wparam lparam. There we go. Now, what this does is I'll explain quickly how the window system and the message system works. Basically, when you click like the X up here, see how it says close? What that will do is it'll send a wm close message, and what that will do is it'll send a destroy message, and then we send a post quit message. And remember up here, wm quit doesn't equal. Well, when we send our quit message, we're telling our application, oh, right now quit. That gets sent, it gets read, and message equals wm quit. We break out of our loop, we shut down, and we return. So that basically exits our application. But you have to make sure that you shut down correctly before you just return. So that's that, but it's a little bit more complicated because we can't. This is actually supposed to be a callback function, but we didn't define it as one because we can't. They can't actually be defined as members. So what we need to do is create a global namespace, basically a throwaway namespace, where we define a global pointer to an app. And this is so that we can use this global message procedure to then pass down, if it exists. We're just going to literally pass along as a sort of a tunnel. We're going to tunnel to our user-defined one, and then if it's not, we're just going. If it doesn't exist, we're still going to make sure that it returns something. So it'll just return the default one. So there we go. This basically pumps messages through user-defined message proc from global space. So basically, it pumps the messages through. And we need to make sure that we actually set that equal to this, so that our app actually exists and it's actually equal just to the our own application. So now we can actually set this to the main window proc, not the message proc we defined, the main window proc up here. Okay, so here we go. Now we can continue. We'll set the icon, which is just equal to load icon null IDI application. Now I'm not going to go into it, but you can actually, that's what resource files are for. You can load in, you can add an HIcon or an ICO file as a resource and then link to it using the ID value, but we're not going to get into that right now. Something that, you know, might be a good thing to look into though, as a little exercise. But get stock object, null brush. What else? What else do we need? Making sure I don't forget anything. Okay, no. So just the class name. I usually just call it whatever the class is, and then WMD class. and then that's null. Also, menus are part of resources, so we don't actually have an H menu. We could create one if we wanted. That would make this right here. This is what an H menu is. It adds one of these. And finally, our icon small. Load icon. Null IDI application. So there we go. So now what we want to do is we want to do some error checks to see if what we want to do is register the class. But if it fails, we want to do something, right? So here's where our utility comes in. We're going to define a little method that's going to return a Boolean, and it's going to be called out error message, and it's just going to take a const char message. We're just going to define this, and literally all it's going to do is going to display a message box with our message. It's going to return false. So it cleans up a bit. It cleans up what would have been a bunch of these. What we can now do is we can just go return out error message failed to register window class. So there we go. So see how nice that is? That's a quick way to do sort of error handling. We'll be defining some things called macros, which probably not something that you should do because that's a C thing. Not really a C++ thing, but whatever. So next, what we want to do is adjust window rect for requested client size. Now, what this is we requested that we want our client size, which basically is the window we draw to be 800 by 600. But if we just pass that in when we create our window, it'll make the window 800 by 600, and the client size will be slightly less, like 740 by something. So what we're going to do is we're going to create a rectangle, R, that's equal to 0, 0, M client width, M client height. We're going to adjust window rect. We're going to pass in R. We're going to pass in our window style that we defined. We're going to pass in false for H menu because we don't have one. And we're going to set the width to r.right minus r.left, int height equal r.bottom minus r.top. We're going to make some x value, x and y values too for its position. What we're going to do is get system metrics, sm cx screen, divide that by 2, and then divide our width by 2. Subtract by our width divided by 2. What this does is it centers the x perfectly centered on our screen, and then for the y, we're going to do the same thing. See y screen divided by 2 minus height divided by 2. So there you go. So now using these things we can set up our windows. So we're going to create our window. So application window equals create window. Create window. The class name needs to be exactly the same as this, so you should just copy and paste. Or define it globally if you want. Define, sort of a static thing. Our app title is what the window name is. Our style is our window style. We have x, y, width, height. And then for these last parameters, for the window parent and the H menu, they should be null. For the H instance, it's our application instance. And for the last one, the L long pointer param is null. So there we go. And now we can again do if not HApp window return out error message failed to create window. So there you go. So now you have that error. See how nice that looks? Nice little quick error message handling. So now we're going to show window. Show our window with the SW show predefined code, and then we're going to return true because everything succeeded. So there you go. So in our init method, what we're going to do is if not init window, return false. We're also going to go if not init GL, return false. Otherwise, return true. So there's our initialization. Now we're going to have to make that initGL method as well. So for initGL, before I start talking about this, I should talk about how you set up OpenGL to actually even work. Now, what we should do is look at this. See the OpenGL, opengl.org/registry. If you move down, there's something called API extension header files. Now, the Windows operating system comes with OpenGL on it every time. If you have a graphics card or an Intel drive, Intel integrated graphics, you have at least some version of OpenGL, above 3.3, and it's the GL and GLU. So the GL and Glue header files are stored in the Windows kit. So those exist. Now what doesn't exist is, what may not exist is the wiggle extensions and the GL extensions. So this right here and this right here you need to get. Now I'll show you what my my folder looks like. So if you go into the Windows kits, now for Visual Studio 2010 it would be something like the Visual Studio 10 include directory. I don't know, you'll find it. Just like do a Stack Overflow search or something. But you go into the include and you go into I have this folder GL, and see I have GL, the header files for GL, Glue, GLU, I should say, Glue, which I'll be talking about in a second. GLU and Glue are two different things. This is the GL utility, and this is the OpenGL extension wrangler. This is GL extension, so Glext. You need to get that. This you don't need. This you might not need. This is for X Windows systems, I believe. So I'm not sure why I even have it. And I know that you need the wiggle extension, so you need this. So just make sure you have at least these. Well, I'll talk about that one in a second, but at least these 5. So you need these 5. Those 2 you probably might not need. You definitely don't need that one. So now where do you get Glue? Now Glue is here. Type in Glue in Google, you'll find it. Basically, it's called the OpenGL extension wrangler. You can find binaries for Windows 32-bit and 64-bit. You click that. You go here and it'll start downloading. And what you'll get is if I can find it, you'll get something to the effect of this, I believe. You'll get these. See, WGlue and Glue. And you'll get the library for Win32, these object file libraries, as well as the Glue32 DLL. Now you need to make sure that the library files for Glue are available. Now if I go into my library for the Windows kit, and I search Glue, See, it's there. Both Glue32 and Glue32S. So they're there. So you'll be able to actually link to them. Now, if you have trouble with this, that's fine. There's a lot of documentation on it. Like, there's a lot of people, reporting that needing help. Linking to things is often kind of difficult and confusing. So what we're going to do is, once you have all that done, we're going to include them. So we're going to include glue first. Glue needs to be included first. Put that, let me make that clear. Then you need to include everything else. So GL, GLU, might as well include the GL extensions and the wiggle extensions. And I believe that's all you really need. Now what we're going to do is link to libraries. So to do this, you should just be able to do pragma comment lib OpenGL32.lib pragma comment lib glue32.lib, and I think that's everything you need. I could check my my engine to see. Let's look. Engine utility. Glue. Oh, you need glue 32. Okay, so we'll add that. Forgot that one. Glue 32.library. Now, one thing you should note is, if I were to go to desktop, what you should do is take that glue32.dll, the one that was in the that came with glue, and drop it right in here. Just drop it right in the debug where your application exists, and that will allow it to actually link to that library. So what I'm going to do is I'm going to actually do that, but for me to do it, I'm going to make it easier on myself, and I'm just going to get the one that's from my engine I'm working on. So see how I have this? So I'm just going to copy that, take that, and paste it right in here. So there I go. See, glue 32. So I have glue now. Now what should happen is it should run fine, with the exception of course, that. So let's return true. And also let's implement that. So create implementation for that, and create implementation for this, and then run. There we go. It ran fine, no errors. So it linked fine to our libraries. Now, if you got errors, it'll probably say like a linker error. That means that it can't find the DLL, or it can't find the library, the includer libraries. The other way to do that, if you need to link specifically, if you don't want to like put it in your Visual Studio includes, you can always include it, select the file, the include and library files directly by doing that, and then go to linker input, and here's where you can put the libraries. So you can essentially put what we wrote here. But enough of that. So let's continue on. Okay, so in a GL. Now the first thing we need to do is create our device context. So That's literally all you have to do to get a device context is you call getDC, pass in your window. So that requires one thing. Your window has to be already created. So there we go. That's one thing. Next thing is a pixel format descriptor. So pixel format descriptor, we're going to zero memory that. This basically describes our window and the pixels that make it up for OpenGL and allows us to interface with OpenGL. So there's a lot of stuff here, right? But the only things we actually need are our end size, which is of course size of pixel format descriptor. We need version, which is equals 1. Layer type is, what's layer type? You know what? Let me look at this. Let's do these first because I know we need these. Draw to window because we want to draw to our window. Support. See here, support direct draw, support GDI, support OpenGL is what we want. Double buffer, that's what we want. So what this is saying is we want the output to be rendered to the pixels in our window, and we want it to support OpenGL, and we want it to be double buffered. So that's essentially what we did there. The pixel type is yeah, there we go. So it's RGBA, so the normal color spectrum, so it's not something strange. 32-bit, and now I think we just want to do our let's see, color bits equal 32. PFD.C depth bits equals 24, and PFD.C stencil bits equals 8. So this is the most common format, basically. Color, 32-bit color, so RGBA, depth bits 24, and stencil bits 8, so D24 or S8. If you're familiar with DirectX initialization, that's what we use there. I think the next thing we need is a format, which is equal to choose pixel format, and you pass in our device context and our pixel format descriptor. And if not, set pixel format. So we're going to try and set it using that pixel format. We want to return out error message, failed to set pixel format. Finally, what else? Okay, now we need to create our render context. So remember that OpenGL render context? Now, context. Now, here's where the wiggle extensions come in. So our handle to our render context is equal to wiggle create context. We pass in the device context. So if not wiggle make current, so I think that's what we have. Because we want to make that actually active. If it fails, we want to out error message failed to create and activate render context. So there we go. So that's setting up OpenGL for use with the Win32 window. So now shutdown is pretty easy. We just do make current null null. Wiggle delete context and release device context. I think we pass it null here, and yeah, I think that's correct. I think. Actually, you know what? Let's probably change it back to that and see if it, if it works. If it works, that's fine. Would make sense to have our window there. So there we go with that. So there we go. Now, one more thing that should probably be done here is we initialize the window. We initialize OpenGL. So one more thing that we should probably do here before we leave is initialize glue. Now, to initialize glue, all you have to do is do glue init. And if that returns from that, it's weird. You see how we did not, but apparently glue init, its error code that it returns is not actually 0. It's like 1, I think. So it's anything other than 0. So what you have to do is you have to just go if glue init. We want to return out error message. Failed to initialize glue. So there we go. So now we're set up and ready to go. Now let's create our test app class. So we don't actually need to include GL utility anymore. We can just include our GL app class test app public GL app. It extends that. Test app takes an H instance just like the GL app. Has a Destructor, overrides, bool init override. If you're using Visual Studio, like you should be, because that's what I'm using. This stuff can, however, be done in like code blocks, but this is a Visual C++ specific keyword. It just makes sure that you're actually correctly overriding stuff. That it's legal, basically. Yeah, we're also going to override this. And we're just going to implement these. Now I'm lazy and I have Visual Assist X, which is, it costs $100, but if you go to a school or work for some sort of business or something, you might be able to get $50 off. I go to RIT in Rochester, so yeah, I got a discount. It's pretty good. So here we're just going to do the base constructor. We're not even going to touch it. Here we're going to call if not GL app init, return false. Otherwise we're just going to return true. We're not going to do anything in update and render yet. Here we're just going to switch on message, and default we're going to return GL app message proc. So that's all we're going to do there. And that's about it. So what we're going to do is we're going to create a test app if not app.init return 1, and then we're just going to return app.run. So, moment of truth, let's see if this actually builds and displays our window. So there we go. So we have our window now. It's not doing anything. I mean, can't really tell if OpenGL is working. So to start, let's calculate our frames per second. So that's the last method we actually have to implement. So here, what we're going to do is we're going to create static float elapsed. We're going to set that equal to 0, and we're going to set static int frame count. And what we're going to do is we're just going to increment these by delta time, and we'll increment elapsed by delta time, and frame count by 1 every frame. And then if elapsed is ever greater than equal to 1 second, what we're going to do is set FPS equal to float cast frame count. And here's where we're going to output to window title. We're going to output some stuff. So what we're going to need is a string stream. Now we have to actually include that, so I might as well include it in the utilities. So we're going to include string, and we're going to include string stream. So there we go. Now string stream, we're just going to out our app title, and we're going to add some space and output FPS. And here's where it gets funky. We're actually going to output some strings from GL. We're going to call GL get string, and we're going to pass in GL vendor. And you'll like what happens after this. We're going to output GL renderer, and then we're going to output GL get string GL version. And then we're just going to set window text to ss.str.cstring. And then finally, we're just going to reset elapsed. Whoa, I keep doing that? Keep doing that. Elapsed equals 0, and frame count equals 0 for next frame. So this is basically our frames per second calculator. Now it should be being called right here. So if we run now, what we should get is a access violation. So iOS forward. So something is not right. So we did something wrong. So let's see what we did wrong. Let's see if it was the OpenGL stuff, because it might have been. Probably was. Let's stop here. Whoa, no. Let me comment out all of this in the old style comments. Let's see if this works. Oh, I forgot to set the window text. So set window text. Okay. So, did we ever yeah, we calculate delta time. So that makes sense because we're not actually doing anything. So let's see if OpenGL is actually working by calling some basic OpenGL functions, and then we'll actually see if OpenGL is correctly working. So here we go. And here, what we're going to do is we're going to call GL clear color. Now, we're just going to pass in some basic colors. I'll pass in red. And then GL clear, GL color buffer bit, and GL depth buffer bit. So now if we run this, it should be a red, we should get a red screen. Okay, so we're not. So that means that something is wrong. We did something wrong. Somewhere in here. Okay, so I took a little bit of time and I figured out what was wrong. So basically, like I always do, I forgot something very, very important. This was not a problem. This I'll talk about that in a second. But the reason the window wasn't turning red is because we actually need to swap the buffers. So yeah, that might be a pretty significant thing to do. So now, see, boom, red. And as you can see, it's like 30 FPS because it should be 60 on your machine. It's 30 because I'm recording, so it takes a lot of hit. Now here, this was a problem with the it being too long of a string. So we're just going to do that again and see if we can finagle it to be not as bad. Render. That's not it. Renderer. GL get string. GL version. No. Version. And let's hope this works now. And doesn't break. Please don't break. There we go. See, so now, depending on what type of hardware you're running, you should see the vendor. So, NVIDIA Corporation. The card, I have a GeForce GT650M, which is like a year old, year or two old GeForce graphics card for laptops, and I'm running 4.3, so I have drivers for 4.3. So there you go. Now I could show you something. Now see how along with the source for this I don't know. Yeah, let's do it. I want to do it. It's pretty cool. We're going to add a new class. Or actually, you know what? No. We're not going to add a new class. We're going to add a new header file. Call this one gcolors, or whatever you want. Just call it colors. We're going to add the pragma once. Define. And we're going to call it namespace. We're going to make a namespace called colors. Now what we're going to store in here is what I'll show you in a second. Now OpenGL, there's a math library called GLM mathematics. Well, let me find it. Here we go. GLM, OpenGL mathematics. Now, this is very good, and you should download it. Now, when you download it, what you'll find is, oh, I just opened up Internet Explorer. That's not what I want to do. what you'll find is a package like this. Now it doesn't have a DLL or anything. It's just straight up you just include the whole thing, the whole folder, GLM folder. So that's what I'm going to do. Literally, I'm just going to drop right into here the GLM file. Includes all the header files. And what we're going to do is we're going to include in here GLM HPP. Now, the reason we need this is for GLM vector 4, which we're about to use. Now, I have already defined a colors class with virtually every color there is in existence. I went through and typed all these out. So I'm just going to copy them in here. And there you go. You have yourself basically every color you could ever want. Now they're extern const because extern const means that they're basically static across. They have like static linkage so that they won't be redefined ever, and they'll be destroyed after use. So it's pretty efficient. And what we're going to do is instead of using these, we can go and use our colors namespace. And the way we're going to do that is literally just go R. We'll also have to add the include, so it adds our namespace. Colors Cornflower Blue .g colors Cornflower Blue. I think this is it. RGB B, and then colors. I forget how to use my own namespace. .a, because I don't know if they map them actually to that or not. I think they do. Let's see. There you go. So now you have Cornflower Blue, and you can use any color you want. Now I will include that. I will include this namespace with the source. You can have it. Yeah. So that's basically the basic setup. You have OpenGL running in a Win32 window. So next tutorial will be about basic rendering, loading shader files, and getting into the nitty-gritty of OpenGL with Win32. Thanks for watching.